Welcome to the Trellix Spotlight series. My name is Nick, and I will be your host. Today's session will focus on the MITRE ATTACK View and IPS DaaS integration in Trellix IPS. This webinar will be recorded. If you prefer not to participate in the recorded session, please feel free to disconnect at this time. A link to today's recorded presentation will be emailed to all registered attendees. This webinar is a brief overview covering common use cases and scenarios regarding this topic. It is not intended to be all-encompassing. If assistance is needed, please contact Trellix Technical Support. If you have questions during the webinar, please type them in the Q&A window. This webinar may run longer or shorter based on your participation, and we recommend asking as many questions as you can to make the most of this series. If the Q&A window is not displayed, click the tab at the bottom of your session window and click on the Q&A icon. We will answer the questions during the final section of this webinar. If you experience any audio issues during the webcast, please drop and attempt to reconnect. Our first presenter today is Kannan Sampath. Kannan is a software development lead for the IPS Manager product at Trellix. He has over 15 years of experience with network products and has been at Trellix for the last 6 years. Our second presenter today is Rachana Kale. Rachana has been a software quality engineer with the Trellix IPS team for the last year. Prior to working at Trellix, Rachana was pursuing her engineering degree. In her spare time, she likes painting. Ladies and gentlemen, Kannan and Rachana.
Thank you, Nick. Welcome, everyone. This presentation is about MITRE ATTACK framework-based attack view in Trellix IPS Manager. So the agenda of the presentation will be overview about the MITRE ATTACK framework, the scope of this feature in IPS Manager, and a demonstration of how the feature works in IPS Manager. So overview. MITRE ATTACK framework is a global knowledge base of adversary tactics and techniques based on real-world observations of cyber attacks. The framework is primarily organized into two main components called tactics and techniques. The tactic component represents the end goal or objective of the adversary, and it is divided into 11 categories. And each category contains techniques which describe how the adversary might achieve the objective. Techniques are further organized into sub-techniques, and each technique or sub-technique is assigned a unique identifier for easy reference. The MITRE ATTACK framework is useful for security practitioners to help them identify and understand the techniques used by adversaries in different phases of an attack, so they can better prevent, detect, and respond to those attacks. And additionally, more details about this framework can be found in attack.mitre.org. So with respect to scope of this support in IPS Manager, IPS Manager supports visualization of the MITRE ATTACK matrix view along with indication of what attacks matches a given technique or a sub-technique. And in the existing attack log view, one can search an attack based on tactic, technique, or sub-technique, and then further filtering based on the tactics, techniques is possible. And further, the report generation is extended to when a report is generated, the details of tactics and techniques can be included in the report. That's the scope of the feature. We'll get into demonstration of the feature in IPS Manager. This is the dashboard of IPS Manager. The manager is already receiving alerts from sensors. In the dashboard, you can see the attacks over time. So the goal of this presentation is to visualize attacks based on the MITRE ATTACK framework. So we'll go into the analysis section. In analysis section, a new node called MITRE ATTACK View is added as part of 11.1 release. So when we click on that, the UI shows the MITRE ATTACK matrix-based view. By default, not all the tactics is shown. So the UI will show only the tactics where there's a matching attack present. I'll switch this knob to show all the tactics and techniques. So now the user interface will show all the tactics and techniques and sub-techniques as how it is represented in the attack.mitre.org. Apart from showing the tactics and techniques for the given time period, so in this instance, I have chosen last 6 hours of time. So for the last 6 hours of time, whatever attacks has been received by this IPS manager. So for those attacks which has matching tactic or technique information is found, that will be indicated by this warning icon. So a user will be able to easily triage attacks based on this MITRE-based tactic or techniques. So for example, in this case, under this tactic reconnaissance, the gather victim network information is highlighted, which means that we have a matching attack for this technique. If I further expand under this technique, specifically the sub-technique network topology has a matching attack. So this way, whichever tactic or technique has a matching attack, it will be highlighted in this format. So from here, we can further drill down to get more details about this attack. So if the network topology is clicked, this will take to the traditional attack log view, where it will show the attacks corresponding to the tactic or technique which we have selected there. So there, the tactic is reconnaissance and technique is gather victim network information. So the matching attacks has been shown here. So here, for these attacks, further drill down is possible. The way user performs the drill down in attack log, the details of the attack will be shown here. What is the application? What is the attacker IP? What is the target IP, etc. So from here, post performing the drill down operation, one can go back to the MITRE matrix view by clicking this back button. So that is how the attacks are mapped in the MITRE matrix view, and user can drill down a specific attack from this view. And further, filters, user is free to add more filter to the existing attacks. By default, time filter is there. Our selection is 6 hours. You can select a specific time filter. And apart from time filter, severity filter and IP address based filter can be added. For example, here we can select an attack severity, and severity is high. So now the attack severity is on. So only the attacks matching the severity high will be shown here. So you can see that the gather network information is not shown. Probably it's not a high severity attack. Apart from severity, the IP address filter also can be added. So the IP address can be either the match can be either with the source or destination. So now for this IP address and this high severity in last 1 hour, there is one matching attack with respect to the tactic resource development and the technique developed capabilities and sub-technique exploits. So when we further drill down, we can see that in the attack log, the filter is applied for high severity. The tactic is resource development, as we saw there. The technique is developed capabilities, and the IP address is 10.10.90.10, which is what we have given as part of filter recommendation. So this is about the MITRE matrix based view that we added support in this 11.1 release. So apart from visualizing attacks in MITRE matrix format, in the traditional attack log also we have enhanced to perform search filter based on the MITRE details. So now we have landed into that traditional attack log page. For last 1 hour, these attacks are present. So the column MITRE attack details is added as part of this feature 11.1. We have added this column indicating for the given attack how it maps to the MITRE framework based tactic, technique, or subtechnique. So in this case, the highlighted attack has a tactic of impact, technique of endpoint, and a specific subtechnique of service exhaustion. So with these new columns, user will be able to perform filtering or searching. So for example, if we have to perform filter based on a given tactic, impact, it will show only the attacks that matches the tactic impact. Similarly, filter can be performed on technique, subtechnique, or technique or subtechnique ID. Clearing the filter. Similar to performing filter, search operation also can be done based on the MITRE details like tactic or technique. Now we have performed search based on the developed capabilities. So the attack log shows only the attacks matching the technique developed capabilities. The search can be done either globally or on a specific column level. And finally, the attack log with this MITRE details can be exported to a spreadsheet or PDF report as well. I'll limit my content to last 5 minutes so that you can save attack log as the CSV file. And report has been generated. And the exported report, as we see, the tactic, technique, subtechnique, the technique ID is present. So yeah, so user can perform the filtering in spreadsheet as well as needed. So that is all with respect to the demonstration of the MITRE-based attack view we have introduced in IPS Manager. Thank you, everyone. Over to you, Rachana.
Thank you, Kanan. Hello, everyone. I am Rachana from Trellix IPS QAT. Today, we will discuss about the IPS to DaaS integration feature introduced in 11.1 M2 release. This is the agenda which I am planning to cover. First, we will discuss about the IPS malware engine. Followed by that, we will have an overview of the DaaS. Then we will look into the down selected logic with the addition of the DaaS. Followed by that, we will see the IPS to DaaS flow. Then we will see a quick demo by configuring the DaaS. Followed by that, at the end, we will look into the troubleshooting steps. IPS malware engine. Categorizing the engines, we have internal and external. Internal engines are running on sensor, example ALBL, GAM, and IPS. External engines are running outside the sensor, example TIS. Again, if we further categorize, it can be classified as hash-based and file-based engine. Hash-based is equal to ALBL and GTI. File-based is equal to IPS and GAM. DaaS supports both hash-based and file-based lookup like VX. Once file is submitted, first it does a hash-based and looks for the file. If not present, it does a file-based because file upload is an expensive operation compared to the hash-based. In DaaS, all the external configurations are done through the manager. Monitoring and alert can be checked through the manager as well. DaaS, detection as a service. DaaS is a dedicated instances running on the cloud. It is similar to VX but not exactly the same. Both the manager and sensor will connect to the DaaS over the domain name and over the SSL channel on port 443. User have an option to choose VX or DaaS at a given point of time. DaaS is configured using an API key generated in the DaaS tool, whereas VX is configured using the IP address. IPS is reachable to Trellix DaaS in both proxy and non-proxy environment. The response verdict could be malicious or non-malicious. File will be extracted and based on that a score will be calculated and we will get the verdict based upon the score calculated. Down selector logic. When file extraction happens on sensor, first it will look for the file in the ALBL if present or not. If not available, it will look from the local sensor cache and check if the file is present. If not, it gets submitted to GTI, then IPS. If not IPS, it will get submitted to GAM and so on. The process is repeated until the file is found in the particular engine. IPS to DaaS flow. First, an API key is created in the DaaS portal. Then on the manager, the same API key is used to configure the DaaS and test the connection. And once the test connection is successful, you have to save the configurations made to the DaaS. Both the sensor and the manager will authenticate with the DaaS over the domain name and over the SSL channel over the port 443. We receive a token from the portal where it is checked every 14 minutes for the availability of the DaaS service. After the connection of the manager, sensor, and the DaaS, file extraction happens on sensor. First, it looks for the file in the local cache if available or not. If available, it will give out the verdict. If not, it will do a MD5 query on DaaS. Since DaaS supports both hash-based and file-based lookup, a MD5 query happens on DaaS. If file present, it will check for the existing report on the DaaS for this file using the MD5. If file analysis report is available, we will get the verdict and the report ID. Assuming the file is not present in the cache, a file upload will happen on the DaaS and we will get a file response which will have the report ID. Sensor will try to do a polling every 2 minutes. Polling is necessary because sensor needs to build its local cache once polling is done. We get the verdict and the sensor local cache is built. Since manager is polling for the report status using the report ID every 5 minutes, once it gets its verdict, an alert will be generated on the manager when it's verdict. The customer need to create a new API key once expired. Now let's go over through a quick demo. So the first step would be to create an API key for the configuration of the DaaS. So this is the tool detection as a service by Trellix. So you'll have to log into the tool and under settings and key management, click on the create authorization key and give a name to your API key and expiry. User have an option to choose the date when they want the key to expire. So user can choose according to their need and generate. So yeah, as you can see here, the API key is generated successfully. Now we will copy the API key that has been generated. Once the key has been copied, now let's go to our manager. So there'll be 2 steps. First would be to create a policy for the files to be detected. So under policy types and advanced malware, give a name to your policy and enable all of the traffic that needs to be inspected, FTP, SMTP, HTTP. Here we would just enable MVX and disable all the other engines since we want the file to be detected, the malicious file to be detected by the MVX engine. So we will uncheck all of the other engines present here. So yeah, as you can see here, we have just enabled the MVX and we have disabled all the other engines. Now we will save the policy and assign the interfaces required. So yeah, as you can see, the changes have been saved to the manager. Now let's go to configure the DaaS under the devices. So there are two ways to configure the DaaS. One would be via the global level and second would be the devices. So if we are configuring via the global level, so for the devices attached to the manager, we can inherit the settings. Or the second way would be to uh, singly configure for each of the devices. We would look into both of the ways to configure the DaaS. First, let us configure via the global level. So under devices, global IPS device settings and MVX integration, enable MVX. So yeah, as you can see, a user have an option to enable the VX or DaaS. We will choose DaaS here. And here, as you can see, a host name is, which remains constant throughout. API key here, we will have to paste the API key that has been created. And here, as you can see, a listening port, which is 443, which is SSL on the port 443. And service status, once the test connection is successful and the configurations have been saved, we will get the service status. And here we'll have to enable the proxy for the DaaS communication. So this is done. Let's click on test connection. So as you can see, here connecting to DaaS and authenticating the configuration. So here it says DaaS to manager test connection is successful. So now let's save the configuration since DaaS to manager test connection is successful. So yeah, as you can see, the test connection between the DaaS and the manager was successful. And once saving the configuration, we have got the service status as running. Subscription status shows as active. And here files API quota daily is 2000. So it's the total number of the files that can be submitted daily with the key created. So now let's go to devices. So under devices, you'll have to go to MVX integration. Here, as you can see, user have two options, either to inherit the settings or enable the MVX integration. Let's inherit the settings and I'm gonna save the configurations. So yeah, as you can see, the settings has been inherited from the global. API key service status shows as running and the listening port is also 443. Here we have sensor to DaaS authentication status. Via the global level, we made the configuration changes from the manager to DaaS authentication status. Via the devices level, sensor to DaaS authentication status is also successful. Now we have manager, sensor, and DaaS authentication status as running. So since we have made these changes, let's deploy the changes to the device made. As you can see here, we have made the configuration changes and the policy changes for the device. Let's deploy this. This is going to take a couple of minutes for the policy and the configuration to be pushed to the devices. Meanwhile, we will also configure via the device level individually. So we choose the device which we want to configure individually. I'm just going to click on enable and here I'm going to click on copy the API key that has been created. And I'm going to give on test connection. and save all the configurations that has been made here. So yeah, as you can see here, the host name remains constant. The API key which we have been created have been copied here. Service status is running. Subscription status shows as active, which means our key is active, and the files API quota daily is 2000. Listening port is 443, and we have enabled the proxy. Sensor to DaaS authentication status via the device level is also successful and running. So we will deploy these changes also to the devices. So as you can see, these changes made via the global level and the inherit settings is successful. Let's just wait for the other. It is also done. So now let's go to our client and see all the configurations made via the sensor CLI command. There is a command which is called show mvx config, which is going to show all the configurations that have been made. So as you can see, a DaaS configuration connection config is enabled, DaaS host name, the port which is 443 and the service status is running. And we have enabled the proxy for the MVX communication. Show MVX start. So as you can see, all the counters are 0 since we have not submitted any of the files now. Now through our client, we are gonna submit a file which is collectmail.pdf, which is gonna try to fetch from its server. So let's try and submitting this file. So the file has been submitted. Let's look for the counters. So yeah, as you can see, the scan request received was 1. And as you can see, the file submission request sent was 1, and we have received the response. The last submitted time and the file which was submitted MD5 and the file name which is collectmail.pdf and the time taken by it was the max upload time. Now let's look into the portal with the key created under submission. So this was the key which we have been created. As you can see here, the file name which says collectmail.pdf, file type, it's hash file, submitted time and date. As you can see here, the status which shows analysis in progress. So we will have to wait for the verdict. Let's check on the manager. So yeah, as you can see here, the file has been submitted to MVX for analysis. We will have to wait for the verdict. So let's look into a few of the other sensor CLI commands. So once a file has been submitted, the report request would also have been sent. Let's just, yeah, as you can see here, there has been a report request that has been pending and the pending list free node is decremented from 200 to 99. Show malware engine stats. So yeah, as you can see here from the malware statistic, file submitted was 1 and the processed has been 1. And the alert has been generated, which we have seen on the manager. It shows as unknown malware confidence because the verdict is in progress. So analysis is in progress. So it shows as unknown malware confidence. Once we get the verdict, it would get changed to other malware confidence, which it belongs to. So we also have a way under devices. Troubleshooting and traffic statistics. and you go to advanced malware analysis. The counters have still not been incremented as we have not got the verdict here. So yeah, as you can see on the DaaS portal, the analysis is completed, which shows the analysis status as analysis is completed. And we have got the verdict, which says the file is a malicious file with the signature name attached to it. So let's look here. As you can see, the report request sent was one, and the report request has also we have got. So we have no report request that has been pending. So the pending list free node is back to 200. We will have to wait for the verdict to get. Since we know it is a malicious file, it will get converted to malware file detected by MVX. Let's try submitting another file. So yeah, the file has been submitted. As you can see here, the scan request received was 2. So the second file has been submitted. Request sent was 2 and the response received was 2. The file name which we have sent, and we have report request sent was 1 and we have got the response. There is one report request which is pending. So the pending list free node has been decremented to 199. And as you can see here, an alert will also be generated. So yeah, as you can see here, for the first file that has been submitted, we have got the verdict, which was the collectmail.pdf. Since it was a malicious file, the file has been converted from file submitted to MVX for analysis to file detected by MVX. So we have got the verdict here. Next, let's check for the second file through the DaaS portal. So yeah, the second file which we have sent was hello.pdf, and the status shows as analysis in progress. So yeah, under devices, troubleshooting and traffic statistics, as you can see here, the file submitted to MVX was 2, and the file processed by the engines were also 2. And the alerts have been generated for each of the file that has been submitted and the unknown malware confidence. Now let's look for the verdict for the second file. So yeah, as you can see here, the status which shows analysis is completed, and the file which was hello.pdf is a clean file. So the alert won't get changed to malware file detected by MVX for analysis. So we can look into the configurations made via the manager, reporting, configurations, the reports, IPS configurations summary file. Yeah, so as you can see here, MVX integration is enabled, integrated with the DaaS, the host name which remains constant, and the port which is called 443. Next is the troubleshooting. So from the sensor side, like for any connectivity, network connectivity issue, the user can check for the show MVX status to check for the connectivity. So yeah, as you can see here, the MVX engine connection status shows as connected, and we have disabled the curl verbose, which we would look into the next troubleshooting step. So suppose if the user face any network connectivity issue, they can look into this and check if the engine has been connected. If we are looking for any specific file submitted information, we can always look into show MVX stats and get the information like what time the file was submitted, the max scan time, MD5 of the file submitted, and if there was any error at for the file submitted. So this would be the command. As you can see here, it gives out a lot of information for the file that has been submitted here. To get like more details, we must enable the curl verbose, which will create a special log under /user/local etc and vxdebug . From the manager side, we can check for ems.log and ems.out.log for the debugging purposes. So coming to the manager help page, on the manager, we have a help page, which is like provided for any configurations help required. There each and every step has been described like how to configure for the VX or DaaS, which would help for the customers to use. At a given point of time, anyone might face an issue related to configuring the DaaS or the network connectivity issue, or there might get an code error called 403, which would result in an invalid API key. So we'll always have to check with the proper API key that has been configured with the DaaS and then test the connection and save the configuration. If we use a wrong API key, we would get an error code of 403, which would result in the authentication status as failed. Thank you, everyone. Over to you, Nick.
Thanks, Kanan and Rachana. As a reminder for everyone, Trellix Education Services offers exceptional training to go along with our award-winning products. If you would like to learn more, please visit the website listed on your screen to see all of our offerings. Now let's get our Q&A session started. I see we have several questions, but it's not too late to add your question. Please type it in the Q&A window to submit. Additionally, take a moment to fill out the survey. Your feedback and suggestions are always appreciated. Can the filter be a range of IP addresses, like 1010.0.024? Did you guys get that? Let me try and repeat that question. Can the filter that you set be a range of IP addresses?
Hey, Nick and everyone. In the current release, we don't support entering range of IP addresses. So it has to be one by one, but still multiple IP addresses can be given, but not as a range. So we can consider it as an enhancement, and we'll create a backlog and we'll consider it as a future enhancement to support range as well.
Got it. Okay, perfect. Thank you for that one. How is detection as a service different from ATD? Can we integrate the MVX on Manager with ATD?
So currently ATD and MVX are different. So we have to separately integrate MVX on Manager. So we cannot integrate MVX with ATD.
Got it. Okay, perfect. Thank you for that one. Does detection as a service integration require any additional subscription licenses from Trellix?
Yes, it's required.
Got it. Okay, perfect. Thank you for that one. The configuration for enabling this engine can also be done via NSCM.
Yes, it can be done by NSCM.
Got it. Okay, perfect. And just to confirm, yeah, it can be done via NSCM. All right, perfect. Thank you for that. All right, it looks like that's all the questions that we had for today's session. I want to thank everyone for joining today's webinar, and a big thank you to our presenters, Kanan and Rachana. As a reminder, a link to today's recorded presentation will be emailed to all attendees. This concludes today's webinar. Stay safe, everyone.